Alright, just a quick little update first. Like I said, I did add in the ability to, you hit spacebar, it'll change your grid, but you got to hit it really quickly, because it'll, so if you get stuck, at any rate, I was just fucking around with some random parameters and crap, but, you won't update your score if you use that key, but, the point is if you get stuck, you can change modes, but again, this could use some real work, but I don't have time to spend much more time on it. So, hit exit key. Yeah, I wanted to, talk about, just remind myself really, just how the game works. Let's see. You can see this game CPP and game H module is part of Chili's framework. And you can see right here the header, it's pretty simple. You can see what kind of variables. This all has to do with that bitmap. You see that CorelDRAW thing, which I just used that because it was convenient. It was on my computer. It was a pretty large BMP because I had to work with uncompressed BMPs. So, that means you can have like icons and crap like that in it. But and that bitmap loader routine, which I covered in a different video. The bitmap.h. Which I imported into this game. This little routine here, bitmap CPP, and you can see the bitmap.h file right here. So this loads a BMP, binary file into the computer, and it's still got a little bit of a bug in it if you noticed, but that needs to be corrected. Okay. So yeah, the little bug it's got in it. You see that little stripe there? It's part of the surfboard. So that's easy enough to correct at some point, but I'm not going to mess with it right now because it's not an issue. Okay, but yeah, this game header file, like I said, is not really that big. You got, like, so this pertains to the bitmap, which I just talked about there, and but again, on that bitmap file, I've got a video on it, in that in one of these sets anyway, because I may actually have that in a different video set. I don't know if it's in my main set here or not. I don't think it might be. Anyway, in pixels, there actually are very few variables in the game because when I was creating this game, you can see, these are the includes right here. So I created, this, which is just a, we can get that over with real quick. It's just a structure, with an X and Y in it. So, and you can see it there. That's all there is to it. No CPP files or anything. But we got our score, and that's for the scoreboard, and that's actually pretty simple. I'll cover it really quick. Where the fuck did it go? Oh, here it is. I just contained it in a header file and only in a header file, so this is all there is to it. This draws a little score, the little score object, and it uses one of Chili's triangle commands because I'd never seen that before, so I just played with it. And it just updates the score. It's self-contained. It keeps track of the score. It has a protected members. Has a tick width and a tick height. I could have just made that private since I don't think this is going to be inherited. But then I kind of used some magic numbers in here, like 3 and shit like that, because I was just in a hurry. I didn't even want to mess with this. But, we draw a little rectangle, a little white box, to signify that there's supposed to be a score there. And by default, it does, give you 1, and that's a little bug in the program. So, but it's okay. I just look at it as, hey, this is the first board, so it's not really a score technically, but it's a score still when you get through the board. Then it updates the score. But we have a reset method if you ever want to clear the score. But then we have an increment score, for when the score increases, you can change your game grid. Because you only get a score if you're done with the grid, if you knock out all the blocks and go to the next level. So we're drawing a rectangle like we said. Let's see. Okay, I'm incrementing our tick width position because we're just creating temporary variables to adjust the position. I should have done that out there, but I was in a hurry. Set the color to some just whatever color I felt like putting in there, whatever color that is. And then we just increment it, based on the score. And so I guess maybe this is why it runs it twice, because I got the less than or equal in. So this is because I use less than equal instead of just less than. That's why we get one score in there. So I could just set that to 0, because that's really legitimately how it's supposed to work. So that way, if you're on grid 1, you won't have a score until you're done with grid 1, but you still know where the white box is if there's supposed to be a score there. Since in this Chili's framework you can't put text on the screen, I mean, we don't have text in there. And that's rather complicated in his framework anyway. Because I know DirectX has some kind of a text rendering command. I saw it in that DirectX 11 wizard created module from Visual Studio, and it renders text. It has that function, but boy, it's complicated to implement. Holy shit! I thought about implementing it in this, but I looked at it. Oh my God, that's like, with all the modules it's dependent on and everything. Holy shit! That would be a real spot of work. That's a lot of more brain damage than I want. But anyway, this draws triangles. Never. The higher your score, the more triangles it draws. But if you see this, this is our increment score method. If the score is over 25, it'll reset to 0. That's just so it doesn't go off to the right-hand side of your screen and crash the program. I got some safeguards in this program, but probably not nearly enough. But anyway, but that's what the score object does. So, and here's our bitmap file, and this is all part of Chili's framework here. So, the paddle object I created, the border object I created, the ball object I created, the brick object I created, and of course the score and pause. So, now the brick object is pretty interesting, but we'll start with the, I'm going to start with the game grid here first, though. You can see, really, we have, just a couple of functions I defined. This is a random function, for for drawing our bricks, so those different screens you saw in the play along video, those are, where, what that's used for. That random number generator is the only thing it's used for. Then we got a setup game function, which actually draws the different grids. But beyond that, everything else is Chili's framework in this module. So I got a paddle object that we create here. It's one of the first things I did. And an is started, it tells us if the game is started or not. And then this is again related to the bitmap. Okay, that CorelDRAW bitmap or Visual Studio bitmap or whatever it is. This also is related to the bitmap. Now here's a border object, because I did create that too. Let's see if that's even included. Yeah, it is. That draws the, kind of fancy border around the screen is what it does. Then here's our ball object instantiated, and then our bricks instantiated. Our obstacle instantiated. And a pointer to obstacle instantiated, a round object instantiated, which this is all really defined in the bricks folder. So the bricks.h and bricks.cpp. It's all defined in there. All these are. That's where they come from. And we got our score object, and then game grid. I don't know what that's used for. Random P really isn't actually used, so it is sort of temporarily, but really it didn't need to be defined here. And this is setting our game grid to 0. Okay, which that's the grid we're on. You'll see that in a second. In our game CPP file, this is all I include, random, and then we got our constructor here, for the game grid. And again, these objects, these 3 objects, need to be instantiated because I cache the GFX object to them. So, so it's got a local copy, in these 3 objects, and only in those 3 objects. So, that way they don't have to have GFX sent to them all the time. But then this pertains to the bitmap, which we've covered in that other video. This is part of Chili's framework. Now this is the update model. What this does, this routine in Chili's framework is where you can do anything you want in here, but this is generally where you process the game input or the game logic. Okay, and down here in the compose frame is where you actually draw stuff. So these are separated out in Chili's framework, and I adhere to that standard for this program, even though it's not necessary to do it that way, but still it's not a bad way of compartmentalizing things. Has its advantages. Now here I go, check to see if the game is started or not, because if it's, if you press return on your keyboard, okay, then is started is set to true, but by default it's false. So it just displays your splash screen, but then when you press enter, the next time it comes through this loop, it'll actually start processing this code. Now, these functions in the ball object actually return a boolean, whether there's a collision or not. But I don't do anything with it. I thought I might, so that's why I just have this dummy variable here. Because I could have gone out and back and eliminated it, but it didn't matter because, like I said, in the future, who knows? I'm going to play with this thing, and that might be a useful thing to know. But I didn't carry on with that in the other objects, but other classes. But anyway, I got a paddle.move paddle. We send it a keyboard object, reference, and a reference to our border object, so it can do collision detection with the border. Then I define, our pointer, set it to blocks. Now the pointer, you'll make note, is actually of obstacle type. Now I guess I got to get into the just make note of that it's obstacle type. Is this pointer, because that's actually a base class. I guess I can go into those fucking bricks just to clarify. Okay, here's the bricks object. Basically, we have a position included, and we use a vector object. We don't really use a string object, so I don't need to include that really. Take that out. I was using it for testing earlier, but I don't use it. Now, we have a couple of enumerations, object type and collision type. So the collision type tells you if the ball collides with a certain object, basically, because these classes are self-contained, everything in here is self-contained. So they act like their own container class, and so when you draw on the screen, it's actually these objects that are drawing themselves, and they keep track of of what sub-objects that exist in a particular type of object, and then they take care of drawing it, keeping track of the position, etc. So, and they determine whether they're destroyed or not, and whether a collision has occurred. They check the collision, but it returns that to our ball object later. So that's why we have this object type, which tells us that there's either no collision, it was a rectangle object or a round object or a brick object that got hit. Now we don't use this technically And you'll see, but again, I thought I might, I thought I might have the ball behave differently depending on which object it hit. Particularly with a round object, I thought I was going to have to get more elaborate with it, and I probably could have, but I just didn't have time. But then you have these collision types, which just returns none by default, even though we don't use it. But the top, bottom, left, and right are principal collision types. But you could do the upper left, upper right, down, lower left, and lower right. I figured for a ball, for a round object collision, I might want to, actually be more precise with the type of collision, in my collision detection routine. But I just left it like it was. It behaved better than I expected, I guess. It just didn't bug me that much. I just don't have time to mess with it. Okay, our base class, which again, this really was a terrible name for the .h file, but originally I didn't know what I was going to call it, so I just called it brick. But I defined a base class and just called it obstacle. But obstacle, what it really is by default, it'll actually draw a rectangle. So any of those rectangle obstacles you see on the scene that can't be destroyed by the ball, that's what they're objects of this class. And in this class, these all work pretty substantially similar, but you'll see that in a minute. But they have a subclass. You have a nested class in it. And that class, has a draw function, and it has its own member variables for width and height. In this case, for a rectangle, its color, which is defaulted to this, and its position, which is defaulted to this, because it's just good to default your, set your variable defaults when an object's created. So when an object is created, these are all going to be defaults. Then you got is destroyed, which, like I said, this is dummy variable here. It's not used in this particular class, but it just, it solves certain headaches with inheritance that I was having, and I may go into that in a sec. But in our base class, it acts like a container class. So, we, have a create object function, and we have an object type, check collision, so it returns object type when that's called. And then we have a collision type, get collision direction. So these two functions are called by the ball, okay, and only by the ball. So they're set up, for interaction with the ball object. But notice we don't include the ball object here, but this is the brick.h is included in the ball.h file. But like I said, this create object, is what we're starting to look into in the game thing. So we pass in a width, a height, a color, and a position, in the form of a pause structure, POS structure, and position for short for it. But then, like I said, the check collision is used by the ball, and the draw object is used by the ball. But the reset is used out in the game. When the game's over, you can come in and destroy all the modules, or all the objects, the sub-objects that are created here. They're contained in this class. Okay, and we have a couple of getter methods, object type and collision direction, which we already looked at. And then we have this vector class, which is of class objects. Okay, and you notice that's our class objects. So this basically creates a vector that contains objects. So, and I call it M obstacles. And we've got a collision type equals GC none, so it's just setting defaults for this variables. And then all destroyed equals false. Like I said, we're not using that here either. That's really for the bricks object, what you'll see later on. But if we go to brick CPP, you can kind of see how this first function works, okay? First object works. So obstacle object, we got create object. So this is our creation method, create a temporary object of the object. So it just makes a temporary object type, and it says object.width equals, we're setting basically all the parameters, that are passed in, from our calling function, from whatever routine called it anyway. So that's setting the defaults for this temporary object, and then basically just pushes that object on the obstacles vector. So, and that's it. That's all that function does. And then we have basically this object type obstacle check collision, which is again only called by the ball object. And it creates a basically, we're creating a temporary little variable here and setting it to no collision type, for this, so by default, it's setting this operation, to no collision, because, we got a position passed into the function, a position object, which is in ball position, and, that's constant because we're not going to be modifying it, and this is a constant, integer, in ball radius. So we pass the ball position and radius in, and this checks for collision. So, it creates this temporary object and assume no collision, and for objects in obstacles that cycles through all stored objects in a vector. So basically, you don't have to, even keep track of how many objects you have. This just keeps track of them. So, it'll keep adding objects, through this create object method, until the cows come home, as long as you keep calling that function. But at any rate, this cycles through all of them and does a general collision test. Okay, so this just checks to see, if basically the rectangle that surrounds the ball, the invisible conceptual rectangle, is, overlapped by our visual conceptual rectangle of our object, invisible conceptual rectangle of our object. But then we set, since we know since this is testing of a collision, if this is true, it'll run this code, right? So we know that OT equals QO rectangle in this case, because that's what this actually is going to be, is a rectangular object. So that is just a barrier. It's an obstacle. So it can't be destroyed. So it's just an obstacle. So signify that a collision has occurred. So basically that sets that, and we'll return that, in the end, once it comes out of this routine. But it does process these various collision conditions. So, it detects, if it was a top collision, bottom collision, left collision, or right collision. Okay, so that'll set our general, member variable for collision type, if one of these types of collisions has occurred. So, then it would be good, to do like combination collisions. So I guarantee you, some of that squirrely behavior is probably partly because of that. Who knows? I mean, I know why it's happening. Chile had the same problem. He went into it, but it's not a mystery. In fact, I had the same problem in the paddle at first, but I corrected it, and I'll show you how if I remember. But at any rate, that covers the check collision, and then we have an obstacle draw object. Now, that all this does basically is it cycles through every object in our collection and calls that particular object's draw function. Because if you can see in here in the nested class that we have down here, it's of type obstacle, but objects too. So it's objects in the obstacle class, and this is the draw function, and basically this is what it does. It just uses the GFX object is passed into it, just like the GFX object is passed into this. Which I don't think I had a nested copy here. I didn't want to use a cached copy because it's like, geez, I don't know. We might be creating a lot of objects here, so I didn't want a bunch of cached copies, into like 500 different bricks. You know what I mean? But as it turns out, if I would have done that, I probably would have done it as, just made a cached copy in the container class. I could have done that, but I wasn't sure what I was going to do yet. So I mean, that's why I don't have a cached copy, because I didn't know if we're going to have like 500 separate bricks, that we're going to all have cached copies. But I could have actually done it and had a cached copy in the container class, but not one in the individual objects. But again, I didn't make up my mind to do it this way until a little later. I had to think about it. But at any rate, you know, we have to pass in a GFX object to this function, which passes it into this function here. So it's really just passed through. I mean, this doesn't actually do anything with it, and this is what actually does the drawing, and you know, sets the width and the height, and draws a rectangle down here equal to, you know, these different positions. So, but this is that little check that I said, you know, in this particular object, you know, the obstacle object, you know, in the obstacle class, you know, I actually do a bounds check, this is a safety check, just to make sure the rectangle is not going to be drawn off the edge of the screen, which will crash the program. So this just makes sure that won't happen, because I figured I might use some random numbers with this. So that's why I kind of put that safety check in it, just to make sure. So it does check if it's being drawn off the right hand side or the bottom of the screen, and corrects it, you know, changes the width if that is indeed going to be the case. Changes its own width, basically. At any rate, that's pretty much all that particular class does. So it just draws all those, you know, square objects that cannot be destroyed by the ball on there. Now, nextly, we have a round object, which is an inherited, you know, class. It inherits the properties from obstacles, so it's a derived class. And because of how the vector thing works, and again, I was thinking about, you know, originally I was going to do this with like a 2D array and do it, you know, somewhere either in here or out in the main program, you know, because I prefer 2D to 1D arrays for several reasons. It's just, to me, it's more readable code. But I decided to do it as a vector, you know, because what the hell, you know, there were some neat features. But one of the problems is you can't inherit it if you're going to change the class that's associated with it. If you're actually going to, you know, if you actually want to modify the class, you got to bring in the new variable object, even if they're named the same damn thing, you know, because you cannot create a virtual class. At least I tried, you know, and I couldn't do it. It said it ignored it. You know, I kept getting a warning saying it was ignoring the fact that I was declaring it as a virtual class. So I mean, you gotta just redeclare the class. The class is named the same here, you know, as it is here. But even though the names are all the same, I still couldn't inherit, you know, the vector, this line of code into this program and have it work with this object. So I had to just redeclare everything. I mean, you know, I practically have almost every function in here is, you know, been brought in, you know, is overriding virtually the functions in the base class. I mean, I think there were just like one or two little methods and, you know, one or two members that it actually inherits from the base class. It was almost silly to have it inherited, you know, in the end. I was really disappointed. But the point is, you know, because I wanted to make this thing draw circles instead, you know, so, you know, this basically does the same thing that other class does, you know, including the collision routine. But that's what was so irritating, is that even though the collision routine I think is identical, I still had to, you know, bring this function in because it couldn't work with the object, since it needed to access this particular virtual method thing. Because since I couldn't just inherit this part of it, you know, I had to bring this into this program for it to actually work with, you know, with the object collection of this program. So I couldn't just inherit this, you know, even this, you know, this draw objects, you know, which is out in the container class, because this is still a container class. But I couldn't, you know, even use that because it, you know, again, the C doesn't realize that, you know, hey, the name's the same. You know, it doesn't frickin' matter. But, you know, the fact of the matter is it does. I mean, you know, it's, you know, you can only, round class, let's see, you know, because here's where the round class is. So we got to create objects, deal, you know, so and this does have to be different, so I had to, you know, make it virtual. And you don't have to make it virtual, you know. I mean, you can inherit like I showed you in some of the other videos in the programming series, the other programming series, you don't have to use the virtual keyword, but if you want to use classes like I'm using them here, which you'll see that in a second or in a few minutes, you've got to actually use the virtual keyword. It's a requirement, but otherwise, you could just overwrite the functions. That's what I did with the class. This class here, objects is the same as this objects, and it just overwrites it. So, in other words, I never inherit this technically from the base class, the round object or the obstacle class, because I'm overwriting it. So, even though it may still technically be part of this class, you can't access it. I mean, it's been overwritten. So, but anyway, that's why I had to, come in here and redeclare this vector over again, and then practically all these functions as well. But you can kind of see what they're doing, and like I said, these are part of the base class here. We had to redefine the collision detection. I'm pretty sure, the only difference between it, is this. So, just sending the identifier to QC round. Again, I really don't honestly actually use these for anything. But again, I just thought that I might. But, really, I mean, this is the only difference, is what that is passed out as from the original routine you see here. If I recall correctly. Look at that and look at that. See, it's pretty much the same code, but I couldn't use it because it's referring to a different M obstacles. Apparently, I mean, C couldn't resolve that. The compiler couldn't resolve that. Just say, hey, this is named the same, but but it won't point to the local version of it. Again, there may be some way around that. I just don't know it. And then here, we also have, as part of the round objects, one of the functions of the base round object class. We have the draw objects, which even this motherfucker I had to re-bring in, because again, this is actually being looked at as a different, so I couldn't use, the draw objects in the base class up here, because C will still think it's referring to, I guess, the object list that was, or the object collection that was, part of the base class. So, I mean, it just gets confused. So, I had to bring this in and make it a virtual function, because originally this wasn't a virtual function. But, I mean, I had to make it a virtual function, just so, it would handle this properly. So, again, this does the same thing. It calls the, because here's our nested class, round object, objects. So, but it calls, this, which again is, not the same. This is different because, it's M radius. This had to be overwritten. So, this function here is the main reason, plus the other, the member variables, the reasons I had to redefine that object class. But at any rate, moving on, we also have a third class, that I derived. This inherits, the obstacle class, to make a bricks class. And again, like the bricks class, it actually does have a nested object in it. It does, but it just inherits everything from the original base class. But that's why I have to put this variable in here in anticipation of that. And this all destroyed equals false. I put this in here even though this type of object can't be destroyed. But I also had to put a, in fact I may not have, but I had to put those two variables in there, but we do have another variable, actually a getter function, which returns whether they've all been destroyed or not. So this variable is defined in the base class, not in this class. So it doesn't have any unique members of its own. Everything it's using is from the base class. But the difference is that it does have a different draw objects command, and it does have a different collision check command because it is a different type object. It's a brick. So, so if we go over to the check collisions, collision check, the only real difference here between this routine and the one for the original obstacle class you see here, that's check collision, and this is its check collision. I've got some different notes in here, I guess, but there's really only the difference is that we have this indicate that object is destroyed in here. So and that it's we're still actually I should return a brick here, but it doesn't matter because, like I said, as you'll see in the ball object, I really don't use this. I just thought I might. So, but it's okay. I don't really return the proper function there, or the proper type. But is destroyed equals true. Indicates the object is destroyed. Okay, that's the only real difference. In fact, that's the only difference. You can see that I actually copied it from the other function. That's the only real difference, is that we deal with that destroyed. But I do have to do a detection to see if an object is destroyed already. That's also different. So so the fact of the matter is, it does have those two differences. But it just checks to make sure that an object has been destroyed. Now, the draw bricks is different too, because remember, this will recycle through our collection. But here, the difference is I check to see if it's destroyed. If it's destroyed, it won't draw a brick. So if it isn't destroyed, it will draw a brick. And then two, we have this all destroyed equals false. Okay, that's different, because I'm trying to see if all the bricks are destroyed. Okay, but right up front, I set it to true by default as you're coming into this function. But when this object's created, it's set to false by default. But going into this function, I set it temporarily to true. And then we go into the objects, and if if even one of them is not destroyed, well, then it'll set it to false. Okay, but if all of them are destroyed, well, then that's being set to true will stick. So coming out of this function when it's left, well, then they'll all be destroyed, and it's time to restart the game, and increase the score, so. But at any rate, the ball object, is intimately related to this, and you can see it's, fairly humble. We got a cached copy of our deal. We got a default color I set there, and that's the color of the ball, actually. We got a, velocity. We have some position vectors that store, or position structures that store velocity, and I got a position default set and a, default velocity set there, and the radius set there, and you can see in the ball, okay, we the ball includes these the bricks object, and the bricks header reference, and the border, etc. But the ball comes in here, and this is a constructor, so it just sets some initial starting variables, for the position of the ball. Is kind of more or less puts it in the center of the screen, while it's also setting up or initializing our GFX cached object in our draw routine. And because I have a cached copy, we don't have to pass GFX in when we draw. So into the draw function. But this basically draws the ball, pretty simple enough, and it's X and Y position, its radius and color. And then we have a move ball function, which this is testing our keyboard. That's what we also, well, let's see, move ball. Okay, the move ball function is not testing our keyboard. It's testing our for border collision, and collision. Just for border collision, I guess. We're incrementing the velocity here. Well, no, I mean, I do have. How the fuck does this work? Okay, keyboard dot left, border dot left. Okay, yeah, this is just doing collision detection with the border, top, bottom, etc., and then changing its velocity, if it hits a border. So that's pretty straightforward. Then we're obstacle collision detection. Okay, so it passes in an obstacle, an object of type obstacle. Now keep this in mind, it's looking for a pointer of type obstacle. Now that was defined in our brick. Okay, but that's the original base class that all these other classes are inherited from. But I'm passing in, a pointer to the base class, not to the individual objects. But this allows me over here in game CPP, to basically pass in, when we're checking the balls for collisions, I just have to pass in one pointer, and then I can just set it to the individual type of object. These are the instances, the instantiated versions of these object, the object class and the round class and our brick class. But we just have one pointer that's actually defined, if you recall, as an obstacle class pointer. So, but we can use that pointer, by assigning it, even though but since these objects here, these blocks and rounds and so forth are all derived off the obstacle class to begin with. Bricks is derived off the obstacle class. Round object is derived off the obstacle class. So I can just make a pointer that points to the base class, but then reuse that same pointer to point to several different class objects. And these are, instances. Only one of these, the blocks class, is an actual obstacle class object. The rest of them are derived. The other two were derived off it. I could have derived hundreds of them and just used one pointer to point to all of them, but since we're using those virtual functions, it will, the functions that are important, it will know to default to the latest version, of those. And, because normally, that pointer, pointer like that could only point to base class members, but since they're virtual, anything that's virtual, it'll actually go to the, instead of going to the obstacle class members and methods, the members in general, it'll actually, look at the methods, for the virtual functions for the class, like the round object and the bricks class. So it'll actually default to the next level up of inheritance, to the most recent version of it that applies to this class here, as opposed to defaulting to the default, in the obstacle class function. So, this allows it to, us to use one pointer, to access several different instances of blocks. Anything that's derived off obstacle, we can, kind of access that way as long as the functions are declared virtual. But other than that, this pointer cannot access other members of a given object. It can't. Like, for example, in our bricks class, we have these, this getter method, for example. That pointer cannot access this getter method because it's a pointer of type obstacle, not of type brick. Even though it's pointing to an instance of a brick object, it still can't access this because this is only declared in the brick object. So it cannot execute this method because it won't even know it's there, because this is not a member of the obstacle class, and it's not declared in the obstacle class as a virtual function. So since this is a non-virtual function, that pointer can't access it, but it can access these two objects because they're virtual, representations of the original virtual functions from here. So, because of that fact, these two functions can be accessed by that pointer. So instead of accessing, referencing, when we use that pointer, instead of referencing, these original versions of that function, it will default to these newer versions of the function. Not newer, but they're just, they're derived from, the bricks class instead of the obstacle class. So that's the point to it. I just wanted to experiment to see if you could use pointers that way, because it's more versatile. Because, you can get into like hundreds of or thousands of instances of different types of objects. Well, if they're all derived off the same base class, you can have one pointer that points to anything and can access the new virtual definitions of any function that you declare virtual, it can access the latest copy or the most relevant copy of that instead of the base class copy, which it normally would only be limited to. But because the virtual keyword allows you to do that, that's why I wanted to do it this way, to experiment with that theory and see how that really worked. But anyway, to get back to the ball thing, we have our optical collision detection, which passes in that pointer like I just discussed. And basically it still works very similar to those other routines. It just checks for collision, with an obstacle, and then, it's pretty simple, as you can see here. So let's see. Yeah, it's pretty, pretty simple. It's even simpler than that other routine for the paddle, technically, or that other routine anyway. Like I said, it's just, it's pretty simple what it does. It's looking for an obstacle type, because we've got obs in. Okay, so it's, bobs in dot check collision, so we're accessing the check collision routine. Hold on. Okay. Now remember, like I said, the objects themselves do the collision detection. So, it's just setting OT equals check collision protect, and it's passing in its position and radius. The ball is passing its position and radius into that calling objects function. Okay, and the interfaces are all the same, for all three functions. So again, it doesn't care what object's being passed into it. It just cares whether it accepts this interface. So, so basically, if OT is not equal to no collision, in other words, if a collision, hasn't occurred, well, it's going to skip over this and just, that's it. Bob's your uncle. But if a collision has occurred, as determined by this query here, then we go through a similar collision detection routine as you've seen before, except that this really didn't do anything except modify its velocity. It just checks to see if OT equals, and again, like I said, we don't really do anything with these types, so I guess I could have set that to brick. I probably had to go do that. QO brick. Okay. But like I said, I really don't do anything with that. I just check, I just do an OR of those three objects, and it's true. If one of those objects has been collided with, otherwise it'll be a no collision, right? So if there's no collision, it won't do anything. But if an object like that has been collided with, well, it does currently the same routine on all three of these. So again, I thought I might have to do a different routine for the circle, or and maybe even want to make it behave differently depending on the type of object. Like I can make it bounce off a certain type of object, like a pinball machine. You have a bumper, that hits, something like that. But at any rate, the fact of the matter is that it does that, and and then basically it looks to see if checks the collision direction, right? Okay, and queries that, and then gets it off whether it's been the top or the bottom or the left or the right. So because the function's pretty much the same, regardless, because it's just inverting its velocity in a given direction. So it's as simple as that. And when we do the paddle collection, which collision detection, which passes in the paddle object. Okay, and I'm not going to bother explaining. It's pretty conventional, but it's a lot more complicated. And I do have that little, eliminates back of paddle dribbling, because that's how I got rid of that dribble problem that you see, when it hugs those squares and stuff, that's how I got rid of it in the paddle, because originally it was doing that between the paddle and the bottom of the floor, etc., but it doesn't do that anymore. And I could probably go fix the others in a kind of similar way, but, to me, I think it's kind of charming. makes it unpredictable, what the ball is going to do next when it goes into that mode. A lot of times it behaves like you'd expect, but sometimes it surprises you. So, but at any rate, I'm not going to explain that any further. We don't need that up. Okay, where's the paddle.h? That's not up. You piece of crap. I'm just trying to move it over here, you fucking piece of douche. God damn this fucking thing. Fucking Microsoft. What a bunch of fucking assholes. Fucking idiots. Okay, so, you can see in the paddle object, this is like the first thing I created was a paddle object. So, you can see, that basically it's pretty conventional class. It's a lot more elaborate. This is the first class, and I was just trying to get my, wings ready to fly on this program, so I was just kind of dribbling around at first. We got several, getter methods, and this is the extent of them, and then we got a couple of, draw methods, and the rest of it's just member variables, and this is the constructor for, for the object right here, so sets our basic positions. I don't think it has a cached copy. Yeah, it doesn't. This doesn't have a cached copy of the GFX object. But if you go into the code here, I'm not going to bother explaining it with you. This is pretty simple. This is all there is to the paddle. It's got a more complex header, than the actual implementation code. So, let's see. But yeah, so that's pretty simple. So I guess we could cover the border here real quick. Let me see. Was I done with the ball? Did I drop the ball? Yeah, no, I wasn't done with the ball yet. Okay. This is paddle collision detection. That's why I got into it. It's a little more elaborate. But then that's pretty much it for the ball object. So, the ball does, collide with the border. Okay. Border.h is right there. Border.cpp is right there. Okay, so here's the border object. It does cache a copy of the GFX, apparently. Let's see. Most of these are just member variables. So if we go look at the, draw function over here, none of this code's really used. So, not here it isn't. But I basically just decided to use the sran function on this. But basically it just draws a series of points using the put pixel command, and it makes the color random. That's why you get that sparkling top and bottom. And then we draw the vertical sides of the border down here. So again, nothing fancy, but that's pretty much all the border object does. But it does have a couple of member variables here that are important. M left, M right, M top, M bottom. These are actual boundary positions. So when you query it, dot left, this will give you the actual collision points that are relevant to a ball or a paddle colliding into it. This will give you the actual points that you care about as a ball or as a paddle, as to where the border is and what your boundaries are. So that's pretty much all it does. And like I said, the paddle object, we're pretty much done discussing that. Here's where it processes the keyboard input. So it's going to take keyboard and a border object into it. So, and I really just do my collision detection right here. So I just have it so it passes the keyboard and the border in at the same time, and, it detects whether, since you're moving here, why not detect if it's fronting into the border or not. It's a simple enough test. So that's why the paddle object is actually quite simple. Again, its header is more intimidating. Its header is actually longer than the actual, implementation code. But, that pretty much covers all the objects, okay? So, going back to the game, you can kind of get a feel for, what's going on with here, with this, and the, we're instantiating, or not instantiating, I think we're doing our collision detection here in this module, because again, this is looking for, this is the module, if you recall from earlier, that, takes care of the motion, takes care of the movement. The setup of the model with the invisible details, you could call them. But it's checking, between collision between a block object, a round object, and a brick object. Okay, but the function handles itself. So, because by calling the ball, that'll determine whether the brick is destroyed, because the brick determines whether it's been hit or not, and it destroys itself. So, but as far as the game itself, this is all there is to it. All the smarts are actually in the objects, for the most part. That just makes sense to me. Otherwise, what's the purpose of object-oriented programming? If you want smart objects, right? But we have the ball, even though I think it could have been smarter than this, still. This is my first attempt at actually, on my own, programming, doing a C++ program with object-oriented programming. So I've never, attempted this before. So I've never really just in a blank program started using classes and all that shit. So that was an experience. I wanted to apply as much of what I learned as I could. Because again, sure, I've dicked around with other people's programs, but that's other people's programs. It's different when you're programming, when you're having to solve your own problems. It's different to see somebody else's code and go, oh, I can change this and this and this. Oh, I can see how this can screw around. Well, when you're starting with a blank slate, it's like an artist trying to figure out what the fuck they're going to draw, right? You get like writer's block. So it's, where do you begin? Well, what are you trying to do? You gotta, it's just a different experience, and I've been through that many times in programming. It's just, you got to start somewhere, and getting started is always the hardest part. But because you got to know what your first thing you got to do is you got to have some kind of vision of what you're trying to do. And I didn't even know what I was going to actually do, what kind of game I was going to make or anything exactly. I just knew it was going to be a breakout-like game, like Chili's Challenge. But I knew I was going to probably deviate from it because I had all kinds of ideas going through my head. I don't have a lot of time here. So anyway, all objects are destroyed. So this just looks to see if all the objects are destroyed or not, and it resets them all, increments the game grid variable, and then calls the setup gain, and also increments the score too in the end. But here you can press a space on the keyboard, and it'll go through that, except that it won't update your score. So that's cheating. So that's like a cheat code. Pressing space bar is a cheat code. Okay, so this checks to see, if the game is started or not, and if it, in the composed frame, and if it is, and I think we've already kind of covered this, maybe not, but that this draws the ball, draws the border, draws the paddle, draws the score, draws our blocks, rounds, and brick objects. So that's all that does, just calls those functions. Some of these you have to pass in the GFX object to, some of them you don't, and these have the cached copies. So, these don't, apparently. isn't started, you know, it draws our bitmap. So, and this isn't relevant to anything. I could eliminate that. Probably creating 50 errors, you know, by going and deleting some of this shit during this video. It'll probably just won't run ever again. Okay, but this right here is the game setup function. And you can see this is the biggest block of code. You know, this just draws all of our grid objects. You know, these first two, game grid equals 0 and game grid equals 1, you know, I just kind of set up manually, okay. But then down here, you know, I start, you know, experimenting with the random stuff. So you can see, you know, random walk being called, which is a function I had defined below here. And I, you know, game grid 3, and then if game grid's greater than 3, then we'll do this. So here's the random function here, and this is just old code that, you know, just ignore that. That's the end of the program. So anyway, that's kind of how it works. I know it's a lot to take in, but anyway, it's kind of an explanation of it. So, appreciate your time.